Hey everyone. So last day of notes for statistics and algebra 2. So we finally made it. Let's go ahead and jump right in. Today we are doing experiments and bias. So you've probably heard the term bias before. Now, specifically for statistics, it's where your experiment or your survey or whatever type of study you're doing, the results from that study are not representative of the entire population. So basically, they don't apply or they don't match up with the real world. These are usually created when you have what's called a biased sample. So a biased sample, remember a population is the entire group that you want to find information about, but you can't always do an experiment for the entire group, so you choose a sample. You'd say, I'm going to choose 50 people to participate. So when you go to choose those 50 people to participate, you have to be careful because the way you choose those 50 people might be biased, which then makes the results from your experiment or study makes the results biased, which you don't want. The opposite of the word biased would be, you might see it sometimes as unbiased or non-biased. Both mean the same thing. Looking at an experiment specifically, so if you think about it like in your science class when you have an experiment, you're always trying to figure out the effects of something. Like you're trying to figure out if singing to a plant makes it grow faster, or if you're trying to figure out whether, this medicine is better to cure whatever. So, whenever you have an experiment, you're trying to find the effects of something, and you have to have at least two groups. One of them is called the experimental group, and the other is the control group. The experimental group is the group that receives whatever you're testing the effects of. And then the control group gets just normal treatment, does not get the whatever you're testing the results of. It's just going to be like the norm. The reason why you need both of them is because you need the control group in order to have something to compare it to. You need basically what is the normal, and then your experimental group is the group that you look at the results from and compare it to the normal to see, all right, did they do better or did they do worse? You could have multiple experimental groups, like you could say, does giving soda to a plant make it grow faster than giving orange juice to a plant make it grow faster, or does does playing music to them all the time make them grow faster? So you could have multiple experimental groups, but you must always have a control group to compare the results to. Okay, so let's just go ahead and jump into the examples. The first one, we're going to determine whether the results are going to be biased or not. So the first one says a soda company wants to find out whether people like their sodas. They survey 500 people at random and ask which soda they like. So if you remember, I mentioned before, usually biased results come from having a biased sample. So let's check this one and see how they chose their sample. Well, it looks like they chose 500 people at random. So taking this at face value, they just chose it at random, 500 people, let's say from just the entire population. Then there's no inherent bias in there. You can pretty safely assume that you're just going to, the results that you're going to get are going to be pretty representative. Now, it would have been better if there were more details on how they chose the 500 people at random, quote unquote. But we can only go off of the information, which just says they chose it at random, which would be unbiased. So the results are probably going to be representative, though we can't say that for 100% fact. The second scenario, it says Alexis wants to see how clean the bodies of water are in her city. She takes 100 samples at random times and days from the pond and lake by her house. So again, determining bias is usually looking at how they chose their sample. So this starts out pretty good. It says that she takes 100 samples at random times and days. Definitely would be good to have random, when you collect your samples can result in bias, but it was at random times, so that's good. But then if you keep on reading, it says from the pond and lake by her house. And therein lies the issue, is that she's only looking at the bodies of water. She's only getting information or data from the pond and lake by her house. But who is she trying to find information about? She's trying to find information about the water in the entire city. So if you think about it in terms of our situation, let's say we want to find information about the water in Hillsborough County. If you just look at the water that's by Newsom High School, let's say, if I had to guess, it'd probably be a little bit cleaner, at least, than bodies of water somewhere else. Or vice versa. She could live by a place that has a really, really dirty pond and lake, and it wouldn't be representative of the entire Hillsborough County, because she's just only getting data from that one place. You have to vary not only when, but also where you're getting your information from, because that can create a bias. So the first one is unbiased, the second one is biased. The next example is figuring out, identifying experimental and control groups. So let's look at this one. It says mice are collected from around the city, and 40 of them have eye infections. Out of those 40, they give 20 of them antibiotic eye drops, and then the other 20 just have their eyes rinsed with water. So you're trying to identify which one's the experimental and which one's the control group. So the control group is usually pretty easy to identify. It's the one that's kind of left alone. In this case, it would be the ones that just have their eyes rinsed daily. So I will do this in blue. Well, I'll just highlight it in different colors. So the control group, I'm going to highlight in yellow, and that's going to be the 20 that have their eyes rinsed with water. Water is usually the control group, unless you're measuring the amount of water, but that's a different type of experiment. But anyways, so rinsed with water is just normal way to clean eyes. But if we want to find the experimental group, it's the one that's getting the treatment. It's the one that's getting something and testing the effectiveness of, which in this case would be the 20 mice that are given antibiotic eye drops. Now, when you write this out, you have to be specific. You would write exactly how it says. 20 are given the, 20 mice, ... antibiotic eye drops. You get the idea. So, and then you would also be specific for the control group. You would write, 20 mice, and then you get the idea. 20 mice that get water. Okay. So that's experimental versus control group. Usually pretty easy to identify. Here's your homework. Last homework of the year. Remember, we have a test that's going to start tomorrow. So tomorrow I'm going to post reviews for everything that we've done since the last test. So that's the graphs of the trigonometry stuff, and then everything on statistics. So I'll post a review tomorrow. I will probably tomorrow afternoon or tomorrow at night, I'll have the test open. Probably tomorrow afternoon. That way, if anybody wants to get it done sooner, they can. So I will open it tomorrow, and it will stay open until Friday. So make sure that you look at the test, or you have all your materials ready to take the test starting tomorrow. Make sure you look at the reviews. And I wish you guys all the best of luck. I was thinking about having a Zoom meeting just so the class can meet, maybe not next week, but the week after. But I'll probably just do a poll on Edsby and see if you guys want to do a Zoom meeting. That way we can see each other at least once during all this stay-at-home stuff going on. All right. Have a nice day.